Santa Fe has a tradition of finding better ways to move the flanged wheel over the steel rail. Using today's technology to prepare for tomorrow's challenges, research experts continue searching for ways to maintain Santa Fe's position as a leader in the railroad industry. There have been many innovations to improve train performance. For example, Santa Fe now has laid over 5,000 miles of continuous welded rail. Regular 39-foot rails are welded into lengths about a quarter-mile long and hauled to location aboard special trains. The new rail flexes like spaghetti as it's put into place. Looking toward improved maintenance procedures, Santa Fe has developed a sophisticated inspection vehicle called a track geometry car. Utilizing highly sensitive measuring devices, this car constantly monitors and records 10 different track characteristics. The latest mechanical engineering techniques are used to design and construct modern equipment to meet the shipping needs of today's industry. Keeping trains running safely and efficiently over the railroad is a continuing challenge. Santa Fe has specialized staffs who concern themselves with the physical and technical problems and potentials in rail operation. There have been some operating challenges requiring research. In fact, in 1974, there were 12 high-speed derailments involving empty cars. 12 derailments demanded reinvestigation to find some common denominators. Of course, a thorough investigation had followed each accident. Cumulative results suggested some directions for further study. From accident reports, it was difficult to pinpoint the problem. There was no explanation for the unusual phenomena of rail cant in tangent track, particularly when the track involved was welded rail known to have excellent surface and alignment quality. An analysis of the derailments revealed 4 common factors. Number 1, the derailments all occurred at high speed. The average speed at time of accident was 66 miles per hour. Number 2, the derailments were all caused by rail canting, or mounting rail. Number 3, the car which triggered the derailment, that is, the culprit car, was an empty in each case. Number 4, many occurred in areas where blowing sand is a problem. As a result of these findings, it was decided to run instrumented tests over a stretch of excellent trackage, but where derailments had occurred. The tests were run with a 6-car consist, powered with 2 EMD SD-45 locomotives. Accelerometers were to measure lateral acceleration on each car, along with displacement transducers to measure rotation of truck. Television cameras were mounted beneath the cars for monitoring the truck and wheel movements during high-speed runs. Controls and recording equipment were located in a special test car. The results were significant and illuminating. Violent truck hunting tendencies were noted at speeds over 55 miles per hour with empty cars. Sulfur cars require greater speed restrictions. The violence of the truck hunting tendencies was found to be directly related to speed, increasing as speed increased. This is particularly true with empty cars. Hunting threshold and hunting intensity are clearly speed-related. These tests clearly show that the hunting forces increase as the speed increases.
27, speed is 50 miles an hour.
At 50 miles per hour, truck hunting is minimal.
60 miles an hour now.
Speed is 60 miles an hour.
Truck hunting increases, and the wheel flange begins to climb the edge of the rail at 60 miles per hour.
Post 720, speed is 70 miles an hour.
At 70 miles per hour with empty cars, truck hunting is severe, and oscillation of the bolsters is noticeable. In contrast, the truck hunting threshold is raised and the intensity is significantly decreased when a car is loaded. The thresholds were raised as much as 20 miles per hour with loaded cars. Videotapes were reviewed by the research staff, and instrumentation recordings were studied. Based upon the accumulated evidence, a report was prepared which included recommended operating procedures. The report indicates that recent operating speed restrictions for empty cars is indeed merited until higher speed truck hunting is controlled. Speed restrictions of 35 miles per hour are applied at blow sand areas, since blowing sand contributes to truck hunting. Careful consideration of the report by Santa Fe operating experts resulted in an operating bulletin outlining speed limits and restrictions. Freight trains handling one or more empty cars are limited to 55 miles per hour. Cabooses and cars loaded with empty trailers or empty containers are considered loads. Loaded or empty unit sulfur trains are limited to 35 miles per hour. Making the railroad safe for everyone is a big job. It takes every man doing his job, thoroughly, carefully, all the time. Your safety and that of your crew depend upon your compliance with the special speed restrictions that are in force on your division.